All right, hi guys. We're on 13.3. We're graphing proportional relationships today. So just as a reminder, proportional means that when you have something that is relatively the same size or the same amount. All right, so our goal is to learn to graph and to write equations for these proportional relationships today. So let's jump down here. I'll just remind you, when I write, you write. You'll complete your notes and then you will submit them at the end of today's lesson. If you don't finish in class, you'll finish up for homework tonight. All right, so your first slide here, how to tell if a graph is showing a proportional relationship. So the points on the graph need to create a straight line. So that's your first blank there. And then part two is that the line on the graph needs to go through the origin. And we can also call that the point 0, 0. All right, so let's take a look at these three graphs here. This first graph is not proportional because it does not go through the origin. It is a straight line, but it does not go through the origin, so it's not proportional. The second graph, this is called a parabola. You'll learn about that in high school, but this is not a straight line, right? So not proportional. This line right here, the third graph, this is a very nice and straight line, and it goes right through that origin, so this line is in fact proportional. All right, so then we can jump down here and we can, how to tell if a table is showing a proportional relationship. So we're going to have sometimes tables, sometimes graphs, sometimes equations, and we will have to decide whether they are proportional. So if we have a table, for example, these tables that are down here, you can determine if the numbers in those tables are proportional because you'll divide each y value, that's your first blank, y value, by its corresponding x value. And then you should get the same answer, meaning if the first batch is 1, then all the next division problems that you do should all be 1. So that value is going to be called the constant of proportionality. So, and I put down that it's the answer because when you do the division problems, you'll get an answer for each problem, and that will be the constant of proportionality, the answer. All right, so let's do these first ones. So when you have these tables, anytime you have a table, the first column is always the x values. The second column is always filled with the y values. Okay, so I'm going to label those as x and y. That's kind of a messy y. Label those with x and y. So I'm just going to take my y values divided by my x values. So y divided by x. So in this case, I'm going to do 14 divided by 4, and I'm going to end up with 3.5 when I divide that on my calculator. So then I'll do my next one, 17.5 divided by 5. So I took the y divided by the x, and again, when I divide on my calculator, I'm going to get 3.5. Great, so far, these are showing a constant of proportionality. So let's try the next one. We have to make sure that they all fit. 21 divided by 6, 3.5. All right, looking good. And then let's try this last one, 24.5 divided by 7. And again, we're going to get 3.5. So in this case, this one is proportional, and my constant of proportionality is 3.5. Now I know it is proportional because all of the answers are the same. All right, so let's take a look at this next one. So again, this is my x column, my hours, and my miles is my y column. So I'm going to divide, and this one is a little bit easier. We can see these visually. So we know 12 divided by 6, that one's going to be pretty quick. That's 2. 14 divided by 7, well again, that's 2, so looking good. 18 divided by 8, That's going to be about 2.25. So right there, I can stop right away. I don't even have to do 20 divided by 9 because if these two answers, so these first two I got 2, they have a constant of proportionality so far. But as soon as I get one answer that's different from the others, then right away I know that this is not a table that is proportional. So there is no constant of proportionality. All right, so I'm actually going to have you just cross this part out right here. Something we're not going to cover in this little unit here. We are going to cover a couple of these quick little definitions. So the equation of a proportional graph or table can always be written as, and we'll fill in an equation here, y equals mx. And we already know what m is. We've been working with m for the last week. So where m is the slope. So m is going to equal the slope of the graph. All right, so the value of the m is the same as the constant of proportionality, which we just figured out how to solve for above. All right, so m and constant of proportionality are the same thing. All right, so we're going to give a couple of these a little try here, and we'll even put together an equation after this. We're going to write an equation. So we're going to tell whether the graph represents a proportional relationship, and then if so, write an equation that represents that relationship. All right, so remember that a proportional relationship has to do two things. One, it has to be a straight line. And two, it has to go through 0, 0, or the origin. All right, so I'm going to look at this graph. Right away, I see a straight line. And right away, I see that it goes through 0, 0. So it is a proportional relationship. So we'll just say yes right away. And then we're going to write an equation that goes through, that would represent this graph. So remember that our equation is going to be y equals mx. The only thing that we have to figure out is what this m equals. And we remember that m is slope. So we're going to pick two defined points on this graph, and we're going to determine the slope of this line. So since it goes through 0, 0, I would always recommend just starting there. That's the easiest place to start. And then we can pick another point on the graph, and there are not defined points, so we have to choose one. And your points have to go through the boxes. So right here, I'm going to let that go away. Right here, we can see where it goes through the corners of boxes. However, if I look right here, this line is hitting, but it's not going through the corners of the boxes. So that's not going to be a great point to pick. So choose the ones that are in the corners of the boxes like that. So I have 2 points right there. I'm going to count my slope. So I go up 2, so that's 2, and I go over 1. So my slope, my m equals 2 over 1, or just 2. Right? Whenever we have a whole number, we could just write it as the whole number as well, or with the 1 on the bottom. So that means my equation is going to be y equals 2x. That is the proportional, the equation that will represent that proportional relationship of this line. All right, so let's check out this guy. Our first job is to determine whether this graph represents a proportional relationship. So, is it a straight line? Yep, it is a straight line. In fact, does it go through 0, 0? It does. So this line, again, it is proportional. So we would write yes, or we would write proportional. Spelled that very wrong. All right, so it is proportional. And so again, we have to write an equation that looks like this, y equals mx. And the only number that we need to fill in is the m. So let's find that slope. So this one, again, it's going through 0, 0, of course, because it's proportional. And then let's just find another box that it goes through. So for example, it goes right here in the middle, the corner of those two grid lines. So we can just count our slope. Now be careful. This graph does not go up by ones. Notice that it's going up by threes right here. So when we go up, that's going up by 3, and then when we go over, it's going over by 1. So your slope in this case, the slope of this problem is 3 over 1. So your equation then is going to be y equals 3x. All right, so our next chunk of slides here are asking us to tell whether this table is a proportional relationship. So we've determined if they're proportional from a graph. Now we'll use a table. And then if so, we will write the equation just like we did before. So again, proportional relationships. What are proportional relationships? 1, they make straight line. So straight line. And 2, they go through the origin or they go through the point 0, 0. Okay, so it has to meet those two qualifications. Now, in a table, we don't see that. So what we have to do is do the division. The third way that you can figure it out is to do the division of y divided by x to see if they all have the same value. All right, when we get to this, we're going to do y divided by x for each of these. Whenever we see something that goes through 0, 0, this is a hint that it may in fact be proportional. We do not have to divide 0 by 0. We're going to get 0 for that all the time, and no matter what, that will differ from all of the other points. So let's go with the other points that we have. So we'll start with this first point here, which is 8 divided by 2. So 8 divided by 2 will give us 4. Then we will do 16 divided by 4, and again, we'll get 4. And then finally, we will do our last one, 20 divided by 5, and again, we get 4. So we can see here that for all of these, we got 4. So what does it mean if we get the same answer for all of them? That it is in fact proportional. Then we can write that equation, y equals mx. And remember what we said. These are the constants of proportionality, these 4's, and a constant of proportionality is the same as a slope. So that means our m is 4. So y equals 4x. And this one is in fact proportional. If we get all the same answers, it is proportional. All right, so let's try this next one. All right, so we're going to, again, divide 1 divided by 4, which we would get 1/4. Sometimes these might even just be simplifying fractions. So in the next one, we're going to get 2 divided by 8. And again, we could simplify that one to 1/4. Let's see if we can simplify 3/12. So 3/12, well, 3 goes into itself once, 3 goes into 12, 4 times, and finally 4/16. So 1/4 again. All right, so all of these are the same, right? Which means we do in fact have a proportional relationship, and we know what our slope is. So we can first write that these are proportional. And we know that our y equals mx, our m is 1/4, so y equals 1/4 x. All right, so we're going to do one more graph and one more table. So for the graph one, I would love it if you try it, give it a try on your own, see if you can get it, see if you can figure out if this is proportional. Now remember that you are figuring out proportionality for the graph. Straight line goes through 0. So give yourself a few minutes and then come back and check your answers. All right, so hopefully you're back checking your answers. So for this first one, is it proportional? It's got a straight line, goes through 0, 0. So yes, it is proportional. Because it's a straight line, it goes through 0, 0. And so we just need to figure out what our slope is. Remember, we need to write that equation, y equals mx. We're going to find out that m is our slope. So I'm going to start my first point at 0, 0, and I'm going to look somewhere to where my line goes through the boxes, and I see it right here. It's going through the boxes, so I'm going to put a point there, and I'm going to count my slope. So this time my slope is going down 2, so minus 2 over 1. All right, so my slope is going to be negative 2. So y equals negative 2x. All right, and then for our next one, for our last problem here, whenever we have these tables, we're going to do y divided by x. If we get all the same answer, then we know we have a proportional relationship. All right, so 6 divided by 2, when we do that, we'll get 3. And if you're not sure, type it into your calculator. All right, 12 divided by 4, we're going to get 3 again. 18 divided by 6, 3 once more. And then 24 divided by 8, 3. All right, so all of these are the same. So is it proportional? Yes, it is proportional. And then you're going to make your y equals mx equation, and the constant of proportionality is your m. Oops, so we wouldn't write m, we would instead write the constant of proportionality, which is 3x. All right, so most of those relationships were proportional. All right, let's try a word problem. This will be a challenge, but let's give it a... All right, so we're going to try out this word problem. So let's do our first step and just read it first. All right, so the distance y in miles that a truck travels on x gallons of gasoline is represented by the equation y equals 18x. The graph shows the distance that a car travels. Okay, so we have two different vehicles, first of all. So the first one is the truck that's traveling on x gallons of gas, and the equation for the truck is y equals 18x. Now the equation for the car is what's down here. So the car is the graph, okay, because we see the car right there. So we have two different things going on. All right, and it wants to know in part A, which vehicle is getting better gas. So let's figure out the truck's gas and then the car's gas. So which one is getting better gas miles per gallon? Whenever we have that something per something else, that's our slope. So the miles per gallon is 18. So the truck is getting 18. So the slope for the truck is 18. That's the number in front of the x, so that's representing our m in that equation. So for the car, we're going to have to do our slope and figure out from our graph. So we could definitely start at 0, and then I see a really good point right here. And so when we go up, that means it's going up by 25, and we go over by 1. So for the car, the slope of the car is 25 over 1, 25 miles per gallon. So which vehicle has better gas mileage? Is the truck, which is getting 18 miles for every 1 gallon of gas, or is the car able to go farther, 25 miles for 1 gallon of gas? Well, the car goes farther, right? So the car is able to go 25 miles on just 1 gallon, where the truck only goes 18. So we'll put car goes farther. So how much farther can the vehicle you chose in part A travel on 8 gallons of gas? Oh, well, if it can go 25 miles in 1 gallon, if it can go 25 miles in 1 gallon, then it could go 25 miles in 8 gallons. If it goes 25 miles for 8 miles, or 8 gallons of gas, then we've got 200. So that means, and if we did the truck 18 times 8, it's only going 144. So the car is able to travel 200 miles, where the truck will only be able to go 144. So if I subtract those two amounts, 200 minus 144, I'll get 56 miles. So the car is going to be able to travel 56 miles farther than the truck on 8 gallons of gas. All right, guys, that's a great job today. Very good. Hold on to those notes, and we're going to do some good practice with that again